Hello, everybody. Welcome back to College Algebra. This is section 4, Algebraic Expressions. This section is kind of like a part 2 to the previous lesson we had, which was order of operations. Algebraic expressions are added into order of operations. It helps makes a complete picture of what algebra is. And so with this section, we are going to implement everything we've learned from order of operations into the same section. So, algebraic expressions. What is an algebraic expression? An algebraic expression contains parts of computations in mathematics that contains operations of numbers and variables. And these numbers and variables will be grouped together into parts called terms. And we're going to look at each of these things individually so that we can have a good picture, an overview of what these things mean. Because you will not do good in mathematics if you don't know how to identify the parts of the terms and parts of expression and know how to utilize them. So, I said an algebraic expression are parts of computation. It's the same way of thinking of a sentence. We have words in a sentence that give meaning to an idea or thought. Same thing for expressions. So this thing right here, I have this little sentence right here. What is an algebraic expression? This is parts of speech. A sentence is composed of parts of speech. An algebraic expression is composed of parts of computation. So we would say, for example, we would have like an x squared plus 3x minus 1. That is an algebraic expression. We have 3 parts. Just as this sentence here has 5 words, what is an algebraic expression? This expression here has 3 parts. X squared, let me use another marker, x squared, 3x, and negative 1. These are the 3 parts to this particular algebraic expression. How do we know there's 3 parts? Not by multiplication, not by division, by addition. And remember, subtraction is simply the additive inverse of addition. So when I say addition, that includes subtraction, because what this minus 1 means is a plus negative 1. Remember that. So it's still addition. It's just addition of a negative number. So we have 3 parts because we have the sum of 3 different terms. Each of these parts here is considered a term. This x squared is a term. This 3x is a term. And this negative 1 this 1 is a term. So how do we go about identifying parts of these terms? What are these parts? A term has 2 parts. I'm going to write it down. You have, let's find a good marker. You have what's known as your coefficient. And you have a variable. A coefficient and a variable. That is 2 parts to the term. T-E-R-M. Your term. So your term contains 2 parts, coefficient and variable. And if the word coefficient kind of sounds like a strange word, it kind of looks a little weird, but think about it. You have let's use a different marker. You have meaning with, and efficient meaning to work or to accomplish. So coefficient, you are working together. So in a term, let's go back over here. We got this 3x right here for this middle term. We're going to use that. Your 3 is your coefficient. Let's try to keep it the same colors, huh? Your 3 is your coefficient. It is the number that works with the variable. Your variable here is the number represented by a letter. So your coefficient never changes, and it always works with your variable. Let's throw another equation up here. I'm gonna show you. It doesn't matter what the equation is. So you saw that right here. This 3x. You have a coefficient. You have a variable. Sometimes you might have one without the other. You may have, notice right here on this equation I have up top, I'm going to erase these circles. This first term, we have a variable, but there's no coefficient written there. On this third term, you have a coefficient. Well, I won't say coefficient, you have a single number, which we will call a constant. So there's actually a there's a second type of term. The first type of term contains a coefficient and a variable. Your second type of term is only a constant. If I can learn to spell. Constant. Why is it called constant? Because it doesn't change. It is static. It is not variable, and it does not change based upon another variable. So these first two terms change depending what the variable is. The second one is -1, never changes. So one type of term is dependent on what the variable is. The other type of term is a constant. It never changes. So notice how this first term right here had a variable but no coefficient. Is that a special type of term? No. It still has a variable. Remember, it's called the identity property of multiplication. Any number multiplied by 1 keeps the same number. So that includes variables. So if you have 1 times x, that is going to equal x. It keeps its identity. That's why it's called the identity property. And we'll get into that really soon. So erase that real quick. So just because you see a variable with no coefficient doesn't mean there isn't a coefficient. There is a 1 there. Remember that. And I believe a few videos back, I made a comment how sometimes when you have, like, for example, x divided by 2, that kind of, and you're trying to solve for something, that might be a little difficult to solve for. But remember, there is that times 1 right there. And we can rewrite this as 1/2 times x. So 1/2 of whatever x is. So it kind of helps sometimes to remember, hey, there's a 1 there. We could manipulate that when we were working with more difficult problems down the road in algebra and calculus. Let's check out another type of equation. This right here, by the way, and it's nothing to memorize right now, but one day we will get into that. This is a special type of equation called a quadratic equation. There's another kind of equation that's really, really common. For example, it looks something like 4 minus x squared, or the square root of 4 minus x squared. This will help define a half of a circle, or the top half of a circle. So we see two terms in this equation. You have a constant 4, and then you have the other term x squared. So we know that the variable for the second term is x. It has a coefficient of 1, and the constant is 4. It never changes. Let's do a problem. I'm gonna give a problem. Let's say we have 2x squared minus x divided by 2. Cool. Now, what does this equal when x equals 3? So all we do is we fill in the spaces, or we fill in the blanks. These x's or blanks, say unknowns. And as a side note, variables, a lot of times they wasn't always called variables. I have a book here. Let me see, which one is it? This book right here, College Algebra and Trigonometry by Coleman and Shapiro. make sure you can see it. Maybe I'm not good with reverse cameras. So this book right here, it's a kind of old book. It's dated from I feel like Math Source were talking about a book on here. That dude is great. 1986. So this book here, it doesn't use variables. It says the word unknowns. So it's kind of cool. I like how you can think of these variables as unknowns because it's a number we don't know what it is until this number is clarified or given to us, such as what does this equal when x equals 3? So that kind of helps us a lot. Let me put this in the back the spot where it's supposed to go. So that helps us when trying to identify what to do when certain situations arise, right? And that stood out. I don't know if that's actually taught in school. I never went to school for math. Believe it or not, I'm a high school dropout. But I fell in love with math afterwards, and I started learning on my own. And now I love math. But I've never seen I've always when I was in high school, at least the first 2 years, I've always seen variable. I've never seen unknown. That to me that was wild, you know. So what is this? We don't know what the x. So we don't know what this x is until it's clarified or defined when x equals 3. And by the way, if some of my teaching or techniques are unconventional, it's because I didn't finish school. I hope that kind of clarifies things if I sound strange in the way I present stuff. You know, I watch videos sometimes, not all the time, sometimes on YouTube, just to see how other people teach things or what it would be like inside of a college classroom, because I never got the chance, you know. But life is hard. Got bills and rent to pay. So moving on. What is this right here? 2x squared minus x divided by 2 when x equals 3. What do? You simply replace the x's with the 3's. So what I like to do, at least when starting out, first rewrite the equation, and whenever you see an x, put a parentheses. 2 parentheses squared minus parentheses over 2. That's what I'll do. It helps you keep everything organized so you don't make mistakes. Because it's very easy to. A lot of times it can get kind of mumble jumble. So x equals 3. Let's plug in our 3's. We got 3 right here, and we got 3 right here. Let's use a different marker. We got 3 right here, and we got 3 right here. So 2 times, what is 3 cubed? That means 3 squared. That means 3 times 3, which is 9. So we got times 9 minus, what is 3 divided by 2? 1.2, right? We can keep it like this. 3 divided by 2. We can keep it like that. So let's go ahead and write 3 divided by 2. Now we have 2 times 9. What is 2 times 9? That is 18. Forgetting to switch back to my other marker. Oh well. Keep it going, right? So we got 18 minus 3 over 2. Now, if you remember from arithmetic, the way we solve a fraction in the whole number, you multiply the whole number by the denominator of the fraction, and then you minus the numerator. So we have 18 times 2. What is that? That is 36 minus the numerator, 3. Come on. I said 3 and I'll write 2 anyway. 3. And then we divide the whole thing by the denominator, 2. Cool. 36 minus 3. This becomes 33 divided by 2. You can always pull out a calculator and check if you're not sure. So we have, let's move on this side. We got 2 times 3 squared minus, is that square root? No, it's square. Minus 3 divided by 2. 16.5. I think that's right. I hate decimal numbers. I hate decimal. You see, when you get involved, if you get involved with something from an applied math field work, you're gonna have a lot of decimals and whatnot. I study pure math, at least for now. I plan on doing physics at some point, but pure math, a lot of times you end up with just rational numbers, but sometimes I guess you do decimal numbers. A fault of mine, I'm not good at decimals. Never did like them. So, and you could check this. Say you might say, and here's a side note. Here's a little side note. You might say, well, how do I know? See, I got the same answer as you. 33 divided by 2. How do I know that's really 16.5? Well, let's clear all this out. 33 divided by 2, 16.5. There you go. It's the right answer, just in decimal format, right? Cool, huh? So variables, you just filling in the blanks, yeah? Let's get a little creative, huh? Let's go with the fun looking problem. I'm gonna think one up. Okay, so I got one fun looking problem here, but I have stipulations. A equals 2, B equals 3, and C equals 4. Now, we have an equation here. A times the square root of 9 plus 12 divided by the square root of C. So, first things first, let's fill in our variables. We have A. What is A? I have up here A equals 2. So we got 2 times the square root of 9. We can do that right now. What is the square root of 9? What number times itself twice equals 9? That would be 3. So we got 2 times 3 plus 12 divided by the square root of C. What is C? C is 4. So we go ahead and put 4 down. Next step. 2 times 3. That's 6 plus 12 divided by the square root of 4. What is that? What times itself 2 times equals 4? 2. Next step. 6 plus 12 divided by 2, 6. 6 plus 6, final step, equals 12. That's your answer. So, it's not difficult. Let's throw something else in there. Let's get even funkier, yeah? Check this out. I got an idea of a good one. Okay, I think I kind of went overboard on this one. So let's see what we got. We have the 8th root of 8 plus opposite or negative C raised to the power of C minus A. You've seen that before? There's a whole expression, an algebraic expression within the exponent. That's wild, huh? So let's see, how can we do this? What do we do? First things first, let's fill in the blanks, right? Let's fill in the blanks. All right, we have the 8th root of 8. What do we have as A? That's supposed to be a B. That was supposed to be a B. The bth root of A. And it sounds weird saying that 8th, bth, cth. It sounds weird, but at least that's what I've seen that people do. So the bth root of 8. How do we write that? So what is B? B equals 3. That becomes the cube root of 8 plus, here we have negative C, or the opposite of C. What is the opposite of C? First of all, what is C? C is 4. So what is the opposite of 4? Negative 4. So we're going to put, and we're going to keep parentheses here, negative 4, and now raised to the power of C minus A. We have C equals 4 minus A equals 2. Look at me writing A instead. A equals 2. Follow? Now, starting from the front again. Next step. Cube root of 8. What number multiplied by itself 3 times equals 8? 2. 2 times 2 is 4. 4 times 2 is 8. Eventually, you will memorize these. Start doing the problems in the back of textbooks, and you'll start to memorize them. You'll be able to catch them quick. So the cube root of 8 equals 2 plus, we have exponent now, so let's keep this negative 4 there. 4 minus 2 in exponent. What's 4 minus 2? Easy, that equals 2, right? That looks so confusing at first, but then now you realize, like, oh, wait, it's just 4 minus 2. It's equal to. Super simple, super cool, right? So now, look at me. Why am I writing sideways? I'm all diagonal. All right, let's try to keep that. Let's try to level that out. So we got 2 plus negative 4 squared. All right, let's do the exponent. We got 2 plus negative 4 times negative 4. Now we're doing negative 4 times negative 4. Why? Because it was in parentheses. Remember the original equation we had written up here? We had this exponent being applied to everything in this parentheses. That's why we didn't immediately make the cube root of 8 minus 4. We didn't set up like that because this negative c, or this negative 4, is still being augmented by this exponent first. Remember, do everything in parentheses first, and then we can apply your additive inverses and whatnot like that. Otherwise, you're going to get the wrong answer. So we have 2 plus negative 4 times negative 4. Remember, your negative times a negative creates a positive, and 4 times 4 is 16. So we got 2 plus 16. It became a positive number. See, if you would have applied that negative to it, we would have already had the wrong number because we would have 2 minus some number. So now we're left with 2 plus 16 equals 18. Awesome. That's so cool, right? Let's do another problem. One more. All right, I think I got a good one. I actually had to pull out the calculator to make sure I had everything the way I wanted it. I didn't want no mess ups like I did last video. I had that messed up. I put the wrong number in the equation. So, all right, let's pull red out. I like the red. Red's really vibrant. I feel like make it a little thicker. There. All right. So first things first, we fill in the variables for each part of this equation. So I have a little bit of A, a little bit of B, and a little bit of C. I put all 3 in this time. So first things first, 5 to the A power. What is A? A equals 2. So 5 squared minus a parentheses. We got 2 to the B power. B we have marked here as 3. So it's B cubed plus 2. Close parentheses, divided by square root of C. We have C marked as 4. So we got the square root of 4 plus the B root of 27. B we have marked as 3. So that's the cube root of 27. Quite the equation, huh? Don't worry, it's super easy. Let's go with purple. What is that? Purple? Magenta? Something like that? So now, next step. No, let's not use purple. That's kind of hard to see. Let's go lime green. That's better. All right. 5 squared. What is 5 squared? 5 times 5. 25. Let me know if I'm not writing big enough on this board, because I don't know. I know some people like to watch YouTube on phones, so I don't know if this is too small, maybe. Let me know in the comments. So we got 25 minus parentheses. We have 2 cubed. That's 2 times 2 times 2. That equals 8 plus 2. Close parentheses. Divided by. We have the square root of 4. That's 2 plus the cube root of 27. What is that? What times itself 3 times equals 27? Let's find out. 2 times 2 times 2. We already accounted that to be 8. Let's go to the next one. 3 times 3 times 3. We get 9 times 3. What is 9 times 3? 9, 18, 27. So we got the cube root of 27 is 3. Now, next step. 25 minus, what is 8 plus 2? It's 10. We should know that, right? Yeah. Divided by 2 plus 3, 5. It's getting super simple. Look how much easier it looks. Scroll down. Let's go orange. 25 minus 10. What do we get? 15. Divided by 5. 15 divided by 5 gives you what? 3. A simple answer. I love a clean, simple answer, don't you? I hope so. So, that was it. That's super easy, right? Don't you think this is great? I love how easy these things get. When you begin to understand the concept of what you're doing, not hard at all. Not hard at all. Not hard at all. I think I'm going to cut the video right there. I think there's one more thing I could have done, but I'm not going to do that right now. I'm going to leave that for when we get a little more difficult lessons. We're going to introduce something called functions later on down the road. So for now, let's scroll this back up. That was algebraic expressions. We were talking about the parts to a algebra problem. The parts of the problem, the coefficient, the variable, understanding that the coefficient times the variable. We got to find out what the variable is, plug it in, and then you can do your multiplication, your division, and all the other terms. And we realize also that it's not your multiplication or division that divides your terms. It's the addition. That is so important when you get into the super higher level mathematics. That is so important. It's what builds the polynomials that we work with for the rest of mathematics, you know? Super cool stuff. Super cool stuff. So algebraic expression, that was section 4. Next section, I haven't decided yet. You'll see, right? I hope you enjoy this. Let me know in the comments if you learned something, if you enjoyed it. And let me know if I could do something better, right? Hope you all enjoyed. See you next time.